From the moment humans first looked up, the night sky has held a deep fascination. The twinkling stars, the distant planets, the ethereal glow of the Milky Way, all sparked a curiosity about our place in the vast universe. This endless expanse above us, dotted with celestial wonders, beckons us to explore its mysteries. For centuries, the unaided eye was our only tool to observe the cosmos. Yet even with this limited perspective, ancient civilizations recognized patterns in the stars, tracked the movement of planets, and developed calendars based on celestial cycles. The night sky wasn't just a spectacle, it was a source of knowledge, a guide for navigation, and a canvas for myths and legends. But our understanding of the universe was about to change dramatically. The invention of the telescope in the 17th century would revolutionize astronomy, ushering in an era of unprecedented discovery and fundamentally altering our perception of the cosmos. No longer confined to observing the heavens with the naked eye, humanity was about to embark on an incredible journey into the depths of space, guided by increasingly powerful instruments that would reveal the universe's awe-inspiring secrets. Long before the invention of the telescope, our ancestors were keen observers of the night sky. With no artificial lights to obscure their view, they could clearly see the celestial tapestry above, and they noticed patterns and cycles in the movements of stars and planets. Ancient civilizations, from the Babylonians and Egyptians to the Greeks and Chinese, developed sophisticated systems for tracking celestial bodies. They identified constellations, groupings of stars that formed recognizable patterns, and used them as navigational aids and markers for seasons and important events. These early astronomers made surprisingly accurate observations and calculations, even without the aid of telescopes. They developed calendars, predicted eclipses, and created star maps that have been passed down through generations. Their work laid the foundation for the scientific study of astronomy. While their understanding of the universe was limited by their reliance on naked eye observations, these early stargazers instilled in humanity a sense of wonder and a desire to comprehend the vastness of space. Their legacy lives on in our continued fascination with the cosmos. In 1609, Galileo Galilei, an Italian astronomer and physicist, heard about a new invention from the Netherlands, a device that could magnify distant objects. Intrigued, Galileo constructed his own version of this spyglass, not for terrestrial observations, but to point towards the heavens. This simple act marked a pivotal moment in the history of science. Galileo's telescope, though rudimentary by today's standards, allowed him to see the cosmos with unprecedented clarity. He observed craters and mountains on the moon, shattering the long-held belief in its perfectly smooth surface. He discovered 4 moons orbiting Jupiter, providing evidence that contradicted the geocentric model of the universe, the idea that everything revolved around the Earth. His observations of Venus's phases, mirroring those of the Moon, further supported the heliocentric model proposed by Copernicus, which placed the Sun at the center of the solar system. Galileo's discoveries, made possible by the telescope, challenged established views and revolutionized our understanding of the universe. His work marked the beginning of a new era in astronomy, one where telescopes became indispensable tools for exploring the cosmos. Galileo's pioneering observations paved the way for centuries of discoveries, demonstrating the power of technological innovation to unlock the universe's secrets. Following Galileo's groundbreaking work, telescopes rapidly evolved. Scientists and craftsmen experimented with different lens shapes and sizes, striving to build instruments with greater magnification and clarity. The refracting telescope, which uses lenses to bend and focus light, became the standard for astronomical observation for centuries. In the 17th century, Isaac Newton developed the reflecting telescope, which uses mirrors instead of lenses to collect and focus light. Reflecting telescopes could be built much larger than refracting telescopes, allowing astronomers to gather more light and observe fainter, more distant objects. The 19th and 20th centuries witnessed significant advancements in telescope technology. The invention of photography allowed astronomers to record and analyze images of celestial objects with greater detail than ever before. Spectroscopy, which analyzes the light emitted by stars and galaxies, revealed their chemical composition, temperature, and motion. Radio telescopes, developed in the mid-20th century, allowed astronomers to see the universe in wavelengths of light not visible to the human eye, revealing previously hidden phenomena like pulsars and quasars. The evolution of telescopes has been driven by a relentless pursuit of greater power and precision, enabling us to probe deeper into the cosmos and unlock its mysteries.